All right, so lesson 8 for unit 1 is over multiplying binomials using area models. Area models is something that we've been kind of talking about earlier this week, where we've been doing the area of rectangles and things like that. So we're kind of building on what we've done already, but we're going to start with a very basic example just to remind you what area actually means. So for exercise 1, we have a rectangle with dimensions of 12 feet and 23 feet. And they say here in the instructions that they want you to multiply using the standard algorithm by hand. What they're referring to is when you set up a multiplication problem like this right here. That's called the standard algorithm. So when we multiply using this standard algorithm, we do 3 times 2, which gives us 6. And then what do? 2 times 2, which is 4. All right, so here's where we got to make sure we remember. You learn how to do this in elementary school. Once I'm done with this 2, I usually cross it out just to make sure I remember I'm done with it. And then I drop down underneath this 6 and put a placeholder 0. Then we move on to 3 times 1 and 2 times 1. And so we get 46 and 230. And what do we have to do with those? Got to add them together. So 6 plus 0 is 6. 4 plus 3 is 7. And then bring down your 2. Kind of got messy there, but that's all right. So it's 276. But if you read carefully, it says include appropriate units. So what are our units for this rectangle? The units are the feet, right? Like whatever you're measuring. So it's 276 feet. We found area. Do you remember what you have to do there? Got to put a squared after it anytime you do area. 276 feet squared. Okay, so what this model, the standard algorithm, doesn't explain or doesn't really help you understand is that the reason for this placeholder 0 is place value. When we're doing 2 times 2 right there, that's not actually 2. That's how much? That 2. It's in the what place? It's in the tens place. So that 2 is worth 2 tens. So it's actually 20. This 1 right here in the ones place is actually 10. So what we need to understand for area models is that 23 can be broken down into 20 plus 3. And 12 can be broken down into what? 10 plus 2. And that's what's happening here on this area model. They have taken the 23 and broken into 20 and 3, and the 10 into 10 and 2. So now we multiply inside each box what lines up with that box. So what lines up with this big box here? 10 and 20. So 10 times 20 is 200. This box on the right-hand side is 3 and 10, so that makes 30. On the bottom, we have 20 and 2, so 40. And then in the tiny little box, we have 3 times 2 is 6. If you add up all of these boxes, on the top, we get 230. And on the bottom, we get 46. What's 230 plus 46? 276. So it's just a different way of viewing that standard algorithm. Those of you who are visual learners, that's certainly going to be a helpful tool to you. We're going to pause there for now because for you guys, it's time to pack up. And then we will pick back up on this tomorrow with the finished video, okay? Part C is going to take that same standard algorithm that we saw in Part A, but now what do we have here? These are not just basic numbers. What are these? 2 terms. So what are those called? Binomials. So we're multiplying 2x plus 3, which is the side length that's labeled here, and then x plus 2, which is the side length labeled here. Using that standard algorithm, watch how we do that with binomials. So we start at the 3 and the 2, just like we did earlier. What's 3 times 2? 6. And then it's a positive 6, right? So we're going to put a plus sign in front of it. And then we've got 2x that needs to be multiplied times 2. What's 2x times 2? 4x. All right, have we multiplied everything in the top times that 2? Yes, so we're done with the 2. Same placeholder 0 concept applies. Put your placeholder 0 here, put a plus sign in front of it just so we keep everything lined up. And then what do we need to multiply? Now by the x, so we got to do 3 times x, which is 3x. It's a positive 3x, so put a plus. And then we have to do 2x times x, which gives us 2x squared. Now we're going to add these up just like we did with the regular standard algorithm on part A. So 6 plus 0 is 6. Bring down your plus sign. 4x and 3x make 7x. Bring down that plus sign. And then 2x squared comes down. So the area of this rectangle is an algebraic expression, 2x squared plus 7x plus 6. That is multiplying binomials using the standard algorithm. On the next example, I'm going to show you how to do it by breaking apart the 2x plus 3 and the x plus 2 using the area model like you saw on part B. So you can see that they've already labeled your rectangle 2x plus 3, x plus 2. And they want you to multiply in each box, just like we did on part B. So what's getting multiplied in this big box right here, the 2x and the x? So 2x times x is 2x squared. What are we multiplying here in this corner box? 3 times x, so that's 3x. What's getting multiplied in the bottom box? 2x times 2 is 4x. And then in this little corner box, 3 times 2 is 6. And it says combine like terms once you're done multiplying. What are the like terms in this box? The x's, the 3x and 4x. What do 3x and 4x equal? We're just combining them, not multiplying them. 3 and 4 make 7x. So once you combine your like terms, you're going to pull each term out. So we've got 2x squared plus 7x plus 6, just like we saw on part C. So that is multiplying binomials. Tomorrow, you'll finish this video by doing part E on the video, and then the second side of the paper is going to be for you to practice and then check after you're done. So we won't do the second part together. You'll do the second part for practice. All right. All right, so for the next example, this is going to be the last one that we do together. Like I said just a second ago, you're going to do the right-hand side of these notes on your own, and then you'll check them with me. So make sure that you use regular pencil that you can erase just in the event that you make a mistake. But really make sure that when you're doing those practice problems on the right side of the page in just a minute by yourself, that you are referring back to these examples that I've covered here to use them as a guide, okay? So for part E, says draw an area model to find the following product. So 4x plus 7 times 3x plus 2. Two binomials that we're going to break apart on this area model. 4x plus 7 and 3x plus 2. Remember that for the area model, you're multiplying each box, what lines up with that box. So for this top left, it's 3x and 4x. When you multiply those, the result is 12x squared. For this box, it's 3x times 7. That's going to give you 21x. Moving to the bottom row, you're doing 4x times 2. That's 8x. And then 7 times 2 is 14. With the area model for binomials, you got to make sure that you look for like terms. So in this case, we have 21x and 8x that need to be combined. Now, we're not multiplying those. We are combining them, which means to add them together. And if you have like different signs, remember your negative sign rules and that kind of thing. But these are both positive. So 21 and 8, that's going to give me 29x. So then we take our 12x squared, our 29x, and our 14, and the product of these two binomials is going to be 12x squared plus 29x plus 14. So that's with the area model. Now I'm going to do it one more time for you with the model that we saw in part C. That's the standard algorithm model. Let me switch colors just so it's a little bit clearer here. All right, so we can take these same binomials, 4x plus 7 and 3x plus 2, and set them up as a vertical multiplication problem. So 7 times 2 is 14. 4x times 2, we're going to put a plus sign, drop it down. 4x times 2 is 8x. We're done with the 2, so we move on, put a placeholder 0 there, and now we're switching to the 3x. 7 times 3x is 21x. That's a positive 21, so put a plus sign. And then 4x times 3x is 12x squared. So you can see we still got the 12x squared, the 8 and 21, which make 29, and 14 and 0 make 14. So we still get this same answer, just a different way to set it up. On the right-hand side of the page, you're going to practice using both of these methods. Refer back to this side of the page with your examples to help you. When you're finished, then